Hello, my dear students. This is Mrs. Suhair Zaki, and now we are going to start a new lesson in our science curriculum for second prep students. Let's start our lesson. Today is with the title Methods of Heat Transfer. And by the end of our session today, you are going to be able to practically identify the methods of heat transfer, which are conduction, convection, and radiation from or to an object. Also, by the end of our session today and our next session, of course, you will be able to describe the applications of conduction, convection, and radiation in heating and cooling processes using common examples. Now let's study some life applications. The first one, cooking utensils. Cooking utensils are made of metals due to their high thermal conductivity. There are conductors, as we have discussed in our previous lesson. So they can transfer the heat energy very easily to the food, and so we can cook our food very easily. So cooking utensils are made of metals due to their high thermal conductivity, while their handles, of course, are made of plastic to allow us to hold the handle of the cooking utensils. The handle are made of plastic or wood to allow the insulation of the heat from our hands, because plastic or wood are insulators and have very low thermal conductivity, as you can observe from figure 10. Also, from our important life application, the wall insulation. It's preferable to use thermal insulators such as polystyrene panels between hollow clay bricks during construction of buildings to avoid the transfer of heat energy from or to our homes or our companies, and prevent to become very hot in hot weather or very cold in cold weather. So we use these type of insulators, which are polystyrene panels, to allow isolation of walls during construction of buildings. These prevent the rapid changes in temperature inside the buildings when outside temperature changes, which reduces the cost of air conditioning inside the building. Of course, to make control in the temperature inside any building, we use the air conditioner. So to allow to reduce the cost of air conditioner systems, we prevent the changes in temperature inside the building by using this insulators, the polystyrene, to insulate the walls and prevent the loss or gain of heat energy from or to the building, and this will reduce the cost of air conditioner systems. Another important life application in electronic devices, such as computers and smartphones, have cooling systems that use good thermal conductors, once again, such as silver. So we use silver to have a cooling system inside smart devices like computers and smartphones. Of course, to dissipate the heat generated in the internal component, which may lead to poor performance or even damage of our smartphones. So during the manufacture of smartphones or computers, companies use isolators to allow the good performance of the device by cooling the device down and prevent the increase in temperature during its performance. So this is our third life application in this part of our lesson. Now let's learn about the heat transfer by convection through the convection current. This is the second method of heat transfer, the heat transfer by convection. Let's observe this figure. In this figure, we will notice an eagle flying high in the air without flapping its wings. The eagle fly without moving or flapping its wings up and down. Let's discuss why and how the eagle can fly without flapping its wings. Any object floating in the air needs what supports its presence in the air, which equals the force of Earth's gravity that pulls it downwards. So any object in the air affected by the force of gravity, and the force of gravity pulls this object down to the earth. So what happens in this figure and during the flying of the eagle without flapping its wings? The eagle remains flying in the air like this thanks to warm air currents rising from the Earth's surface, called convection currents. So the convection currents, which is the warm air currents rising up from the Earth's surface, hold the eagle in the air and allow flying of the eagle. These currents are called convection currents. Now let's do an activity to explain what is meant by convection currents. We will need in our experiment some materials and tools as follow. We will need some water, potassium permanganate, beaker, and flame like here in the figure. In our experiment, we will begin to place a beaker containing a quantity of water over the flame like here in the figure. Then we will drop a crystal of purple potassium permanganate into the beaker. Potassium permanganate is one of the chemicals that has very distinguished violet color or purple color, and when we drop it in the water, it begins to spread out through the water liquid inside the beaker. So we will use the flame to heat the water inside the beaker. What will happen? What do you observe during heating process? What will happen when we heat the beaker after dropping down the crystal of potassium permanganate inside the water? What we will observe? Of course, we will observe the spreading of the color of potassium permanganate in the water. So how can we explain what happened? When the container of water is placed on the heat source, the water particles at the bottom gain thermal energy, and so its density becomes lower, so they begin to flow upwards and replaced by cold particles of water. The hot water particles move faster and further away from each other, resulting in decreasing in the density of hot water, so hot water begins to rise up to the top. At the same time, the cold particles of water has higher density, So they begin to sink down to the bottom and replace the hot water. This is called the convection current. So when we heat a liquid, like here in the figure, the particles at the bottom begin to gain thermal energy. So they become hot, they move faster, and their density becomes lower. They move up and replaced by cold particles that has higher density and move down. So heat transfer by this method is known as convection currents. This is the convection currents that we have talked about, which occurs with the movement or the currents of liquid and gaseous fluid particles, like here in figure 16. And now let's study one of the life applications related to heat transfer by convection currents. The space heater is placed on the floor of the room, like here in the figure. So the heater is on the floor or on the ground, not hanging upwards but downwards. Why? Let's explain why. Of course, heat is transferred from space heater to the air around it, causing the warm air to rise up and replaced by the cold air. So the same here happened with air particles. The space heater heat the air particles. This will make the warm air less dense than the cold air. So the warm air rises up and replaced by the cold air particles that falls down. And so the space heater will heat up the cold air once again. This is the same of the convection currents that we have studied in water, the same here in the air. So heat transferred from the space heater to air around it, causing warm air to rise and cold air to descend down to replace the warm air, and so the heat distributed throughout the room. Another life application, which is one of the wonderful phenomena that take place in our environment, which is called sea breeze. Let's learn about it. It's a natural phenomena that occurs because the temperature of land rises faster than the temperature of water during the day, as the specific heat of the land is lower compared to that of water. We have learned in our previous lesson that the specific heat of water is high, while the specific heat of metals and solids are lower than that of water. So what happened during the effect of heat of the sun on both land and water? The land is heated up very fast, while water needs much more time to be heated. So what will happen? The air in contact with the land heats up more than the air above the surface of the water. So above the land we have hot air. Above the water we have cold air. The air above the surface of the land becomes lower density and lighter, so it rises up and replaced by the cold air that coming from the sea. So this is called the sea breeze. When we are with our family in the north coast, لما بنبقى في الساحل مع العائلة, we will observe the cold wind that comes from the sea to us. This is called sea breeze. Sea breeze happened because the land is heated very fast and it heats up the air above it in contact with the land, while above the sea the cold air exists because the water has high specific heat, so it's cold, and the air in contact with the cold surface of the sea is also cold. This allows the exchange of the air particles. Hot air moves to the sea and replaced by cold air coming from the sea. This phenomena is called sea breeze. So the effect of this phenomenon is more perceptible or can be felt in summer than, of course, in spring or autumn. So in this phenomena, hot air rises up and cold air moves down. Then the cold air moves from the sea to the land, and hot air moves from the land to the sea. Now let's evaluate our understanding by this question. From figure 19 here, how does heat transfer from the heater to each of the following? At the first, object X. Let's study together this figure. We have the heater down on the ground. We have an object X right on the top of the heater, and we have a table, and on the table there is another object Y. So in case of object X as we observe from the figure is in contact with the heater. So when the heater begins to heat up the room, object X is in direct contact with it. So heat transfer from the heater to object X by conduction. From the same figure, what is the way the heat transfer from the heater to object Y? Object Y is away from the heater and locates at the top of on the top of the table. So it needs to be heated up. For heating up object Y, we need the air currents to be exist, and this is called heat transfer by convection currents, in which, of course, the hot air rises up and replaced by cold air that falls down. Now let's study together the third method of heat transfer. The third method of heat transfer is the heat transfer by radiation. Heat transferred by conduction and convection methods through the particles of matter. We have studied heat transfer by conduction and convection. In each one of them, we need a medium, we need material and particles to allow the transfer of the heat. So what happened when the heat is transferred from the sun to the earth? However, if we thought about how heat is transferred from the sun to the earth across the millions of kilometers of space between us and the sun, let's think together. In this case, the solar radiation that consists of electromagnetic waves travel through space with a very high speed, reach to 300,000 kilometers per second in all directions, and heat transfer by the third method, which is radiation. So some of these waves of electromagnetic waves are visible, such as light waves, and some of them are invisible, such as infrared rays, which have the thermal effect. When substances absorb infrared rays, their temperature rises, which is why we feel warm when you are exposed to solar radiation. So infrared rays are the type of invisible rays that come out from the sun and carry the thermal energy of the sun. And that is why when we exposed in the sun, in an area exposed to the sun, we feel hot. Why? Due to the effect of infrared rays that has thermal effect and make us feel warm or even feel very hot in summer season. So, hot objects are also sources of infrared radiation. A big dark object can absorb infrared radiation better than light-colored objects or shiny objects. That is why we wear dark-colored clothes in winter to absorb infrared radiation and to allow us to feel warm in cold winter weather, while in summer season we wear light colored clothes or shiny clothes to allow reflection of infrared radiation. And also that is why firefighters wear shiny silver clothing, while also the pipes of solar heaters are painted black to absorb more infrared radiation and allow heating up the water. From our recent technological application, the thermographic camera, which is a camera or a device that can detect the thermal radiation emitted by objects to detect the infrared radiation or rays and converts it into colored images. Like here, this man emit the heat energy in the form of infrared radiation, and so this is his photo by this type of cameras, which is thermographic cameras. These colors depend on the change in temperature of the object. We have different colors, and this shows us the different parts of changes in temperature of this body. These cameras are used for imaging in the dark and for detecting the temperature of object. Let's study this topic. It's an integration of science with biology. It's about the snakes. Snakes are able to hunt their prey at night because they have sensory receptors at the front of their head. Here, in the front of the head of the snake, there are sensory receptors that enable them to detect infrared rays emitted by their prey. So the snake can detect the prey، تقدر إن هي تصطاد الفريسة by sensors or sensory receptors detect the infrared rays coming out from their prey. So they can hunt in the dark or in the night due to the presence of these sensory receptors that detect the infrared rays coming from their prey. Now let's evaluate our understanding. From this figure, identify the methods by which heat is transferred, indicating by numbers from 1 to 3. Let's detect the first one. Number 1. What is the method by which heat is transferred from the fire to this part. Of course, heat transferred in this case by radiation. So this is the first method. What about number 2? How heat is transferred to the metal handle of this pot? Yes, of course, the method here is by conduction. So heat transferred to this part by conduction. The third part of our question from the figure: how can heat is transferred to this liquid inside the utensils or in the pot? Of course, in this case, heat is transferred by convection currents, which allow the hot particles which have low density to rise up and replaced by cold particles with higher density that falls down. And these convection currents allow the heating up of this liquid. Now another question: evaluate your understanding. Choose the correct answer for the questions from 1 to 5. When a tray of pies is removed from the oven and placed on a metal surface, what happens to the cold air outside a kettle when it comes into contact with its hot outer surface? What happens to the air when it becomes in contact with its hot outer surface? Let's see our choices. The first one: its density decreases and it sinks downwards. The second one: its density decreases and it rises upwards. C: its density increases and it sinks downwards. D: its density increases and it rises upwards. Of course, when the air becomes heated up, the density of the particles of the hot air decreases, so it rises upwards and replaced by cold air. So we will choose B: air density or air particles decreases, the density decreases and it rises upwards. Evaluate your understanding. And another question: give reason for the following. Number 1: the concept of heat is different from the concept of temperature. Why heat and temperature are two different things? Let's explain what is meant by temperature and what is meant by heat. Temperature measures the average kinetic energy of the particles. So temperature indicates the measurement of the average kinetic energy of the particles of the matter, while heat is the thermal energy that can be transferred between two systems, from one system to another. It depends on the difference in temperature. So the heat is the thermal energy that transferred from the system with the higher temperature to the system of the lower temperature, while temperature itself is an indication of on the average kinetic energy of the particle of a system or in a certain matter. Evaluate your understanding and another give keys. Number 2: placing polystyrene panels between the bricks of the walls. Why? to isolate the walls and prevent the transfer of energy from it or to it, and so we reduce the cost of air conditioner as we discussed in our lesson. Now our last question, evaluate your understanding. We have A and B are two quantities of water. Temperature of A is 40 degrees Celsius and that of B is 5 degrees Celsius. Which of the following graphs shows the change in temperature when they are mixed together? What happened when we mix A and B? A and B, once again, are equal quantities of water, but temperature of A is 40. Temperature of B is 5 degrees Celsius. What will happen when we mix both quantities together? Of course, we will observe that the temperature falls down from 40 and rises up from 5. Then we will have a temperature between these two temperatures due to the exchange of heat energy between the medium particles. And if we study these graphs, we will observe that graph A describes the falling down of A and rising up of the temperature of B till they reach the same temperature. It's about 22.5, while graph B shows a falling of A temperature and rising of B temperature more than A, and this is nonsensical, of course. Graph C show that there is no any change in both A and B. They have temperature A doesn't change, it remains 40, while temperature B is 30, and this is completely wrong. In case of D, the temperature of A falls down while temperature of B rises up, but they will not have the same temperature at the end of the graph. So from these graphs we will use the first one, which is A graph, that indicates the falling down of A and rising up of B till both of them have the same temperature. This is the thermal equilibrium that will take place in this experiment, and the final temperature will be 22.5 degrees Celsius. This was our last question in our session today. Me, Mrs. Sohair Zaki, was with you, dear students, under the supervision of the science consultant on the Ministry of Education live stream platform. See you next session, inshallah.